Welcome to part 2 of the vertical projectile motion velocity time graph, and in this video I'll be explaining the properties of a velocity time graph. But just to recap on the last video, we answered two questions, right? So the first question was it a drop or a throw? Okay, so for this question we looked at the initial velocity, right, of the object. So we said if the initial velocity is equal to 0 meters per second, then we can simply say that that object was dropped from a stationary object, right, or from a stationary point. But then, however, if the initial velocity is a certain value which is not 0, we used 2 as an example, then we can simply say this was a throw, right? And then whether it was thrown upwards or downwards, that was the second question. So the second question was, where did the object go? So if it was dropped, then we expect it, due to gravity, we expect the object to go downwards, okay? But then if the object was thrown, then it's either it was thrown upwards or downwards, right? But then how do we actually check whether it was thrown upwards or downwards? If it reaches a maximum height first, then we can simply say it was thrown upwards, right? And then if it bounces first, then we can simply say it was thrown downwards. And all this information you can see from the velocity time graph, okay? And then but then for this video I want to explain the properties of that velocity time graph, okay? So number one, we can see that on the y-axis, okay, you have your velocity in meters per second, and then on the x-axis you have your time in seconds, okay, and that is your 0 point there at the origin. All right, so if you check on the y-axis, since we have velocity, we can calculate, or before we start calculating, we can see that we have the velocity, and on the x-axis we have time, right? And from the previous examples that I've been showing, you can see that all these graphs were straight lines, right? So all these velocity time graphs are represented by a straight line. So a straight line is in the form of y equals to mx plus c. So let's say, for example, we have a graph like that. Okay, let me use a different color. So we have a graph like that. So number one, we have to answer the first two questions, right? Question number one is, was this a drop or a throw? Okay, so we said you look at the initial velocity. Your initial velocity is equals to 0. This simply means that the object was dropped from a stationary point, right? All right, so if the object is dropped, where did it go? Obviously, if it's dropped, it should go downwards to bounce, right? So you can see that this object went to bounce. So if it went to bounce, then it means it went downwards. Okay, so now I was saying, if we can calculate the gradient of this line, okay, and that is property number one. If we can calculate the gradient of that line, we can see that that is a straight line. So the gradient is equals to change in y over change in x, right? But then now, since on the y-axis we have velocity, then it means our gradient is equals to change in velocity over change in, on the x-axis we have time. So meaning it will be time, right? But then now, from the definition of physics, the change in velocity per unit time, okay, so this is the change in velocity per unit time. By definition, that is what we call acceleration, okay? So acceleration is the change in velocity per unit time. So we can say, from the definition of acceleration, we can simply say that this gradient is actually the acceleration of that projectile, okay? So now, question is, what is the acceleration of a projectile? So from the theory that we have explained in the previous videos, we said the acceleration of a projectile is constant, okay? And the acceleration of a projectile is the same as the gravitational acceleration, which is 9.8 meters per second squared. And the direction is downwards because acceleration is a vector. So this is very important to note, that the acceleration of a projectile is always 9.8 meters per second squared downwards, right? So what could be the conclusion on this graph here? We can say that, right, fine, we said the gradient is the acceleration, right? That we agree. The gradient is the acceleration, but however, the acceleration is equal to the gravitational acceleration, which is 9.8 meters per second squared downwards. Okay. So if a question asks, and then let's say there's a question that says, what physical quantity does the gradient represent? What physical quantity does the gradient represent? So you can see that this is a straight line, right? It has a gradient, and we said the gradient is acceleration, and that acceleration is actually your gravitational acceleration. So your answer would be, it represents your gravitational acceleration, or simply it represents the acceleration of that projectile, right? So that is answering the first question. What is the what physical quantity that does the gradient represent? And maybe question number 2, what is the value? What is the value, or let's say, what is the numerical value of the gradient of the line? Okay, so we can see that question number 1, what is the physical quantity? That is the gravitational acceleration. But what is the numerical value of that gradient, or of that gravitational acceleration, right? So if you look at our graph, we said the gradient is 9.8, right? But if we look at the graph, this is a straight line with a positive slope, okay? So it means that the gradient here is actually positive 9.8, okay? So in this case, it's going to be positive 9.8. That is the numerical value, okay? But then what if we had a graph like that? Okay, so this is your velocity x, that is your time, and this is your graph. So question number 1, was it a drop or a throw? initial velocity equals to 0, so it was a drop. And where did the object go? Obviously, if you drop it from a stationary point, it's gonna go bounce, so the object went downwards. And then now the next question is, what is the physical quantity represented by the gradient? The physical quantity represented by the gradient is acceleration or gravitational acceleration. So now the next question, what is the numerical value of the gradient? We can see that, fine, we know that the acceleration is 9.8, but however, we can see that this line is a straight line with a negative slope or with a negative gradient. So it means that the numerical value for the gradient now, it will be negative 9.8, right? Because that is a line with a negative slope. All right, so that is the first property. The first property talks about the gradient of the line. The gradient of the line is the acceleration from the definition of acceleration. And also that gradient is 9.8, right? Which is your gravitational acceleration. So on the question of numerical values, what is the numerical value? It depends on the slope of the line. If it's positive, then it's positive 9.8. Then if it's negative, if the line is going down, then it means this is a line with a negative slope. Then the answer would be negative 9.8, right? All right, so now let's go back to this graph. If we look at this graph, we have explained property number 1, which is your gradient. Now let us explain property number 2. So property number 2 actually talks about the area under the graph. Okay, so property number 1, we are done with it. That was your gradient, and that gradient is 9.8 meters per second squared downwards. Okay, and then property number 2 actually talks about the area under the graph. So it's the area under the graph. So the area is between the graph and the x-axis. Okay, so the area is between the graph and the x-axis always. So this is the x-axis right here, which is your time axis. Okay, and that is your graph. So the area in between here, that is property number 2. Okay, so the area under the graph, that represents your displacement. So that represents your displacement. So if you can see that this shape is a triangular shape, right? So it means the displacement in this case, then it would be half, which is the area of a triangle, right? Base times height. So the base would be this time axis. So it would be that length from there to there. So that is your base, right? And then your height is this length here, which is your velocity axis, right? So if you take those two sides and you calculate your area, you're actually calculating the displacement of that projectile. Okay, so that is property number 2. So if you were to get a question that says what physical quantity does the area under the graph represent? So in this case, we looked at a question that says what physical quantity does the gradient represent? And we said that the physical quantity represented by the gradient is acceleration, right? And which is 9.8 meters per second squared. But then, however, now we are talking about the area under the graph. So if we were to get a question like this, we'd say the physical quantity which is represented by the area under the graph, that is simply your displacement. So that is your displacement, which is delta y for vertical projectile motion. All right, so we have explained the two properties that I wanted to explain in this video, and in the next video we're gonna explain how to actually identify the direction which is chosen as positive. Okay, but then before I end this video, I just want us to have some explanations on this velocity time graph. Remember, the aim of this velocity time graph, or the aim of this graph, is to eliminate statements, right? Actually take a long statement and put it in a graphical form so that it's easier to explain. And it's easier to explain if you ask yourself the questions that we have been asking ourselves. So the first question would be, was this a drop or a throw? We can see that that is your velocity axis, that is your time axis. Okay, we can see that this ball, it was not a drop because the initial velocity is not 0. There is your initial velocity. Then we can simply say a ball was thrown, right? And what is the initial velocity? The initial velocity in this case, we can see it's that letter L, right? So the initial velocity is equal to that letter L. So this was thrown, okay? And then question number 2, where did the object go? Where was it thrown? Was it upwards or downwards? So we can see that as we continue with the graph, this reaches maximum height here at velocity equals to 0. Okay, so here velocity is equals to 0. It reaches maximum height first before it bounces. So meaning it was thrown upwards. Okay, from what we have been explaining up here, to say if it reaches maximum height first, which is that line, okay, then we can simply say it was thrown upwards. But if it bounces first, then it was thrown downwards. All right, so we can see that we are formulating a statement now. We are saying a ball was thrown with an initial velocity of L, and that ball was thrown upwards because it reaches a maximum height, right? And then after this, we're gonna have more videos explaining on what happens after it reaches the maximum height. Obviously, it's gonna come back down and then it's gonna bounce, right? All right, so let's continue with the questions that we have done so far. So the next question is, what is the physical quantity represented by the gradient of the line? We can see that these are straight lines, right? So they do have a gradient, and that gradient, we said it's acceleration. So the gradient is acceleration, and that is gravitational acceleration, and that is equal to 9.8 meters per second squared downwards. Okay, and then the next question, what is the physical property or quantity represented by the area under the graph? This area under the graph, and remember the area should be between your graph and the x-axis, right? So the area represented, the physical property represented by the area under the graph, that is your displacement. So if we actually calculate the area under these graphs, and these are triangles, right, we can actually compute, or we can actually calculate that displacement. All right, so that's it for this video, and then in the next lesson we'll be talking about direction and more on these vertical projectile motion velocity time graphs.